So on the top of the page, you have 6 functions. This is nothing new. These are the functions we've been working with. But the problems will use these functions when we try to combine them. So first, notation. What does it mean to have h of 20? What does this notation mean? What do we need to do? Huh? H of 20. I find my function h in the list of my functions. Here it is. H of x is square root of x minus 4. But I need to evaluate this function for x equals 20, right? So I just copy my function, but instead of my x, I put what? 20. And then I just evaluate this expression, right? So 20 minus 4 is 16, square root of 16 is 4. So that's my answer, right? Okay. Now, what happens when I have two of these? Two different functions, g of x and f of x, and I'm asked to evaluate g of 3 plus f of negative 1. What will I do? I will look up what my function g is, right? And g is x minus 4. I'll put it in the parentheses, just so everything is clean. Oh, I'm sorry, not x. Don't do x. Right, but instead of x, so I'll put something in the parentheses for g. So instead of x, I have another parenthesis, leave a space, minus 4. And what goes inside those parentheses? G of 3, right? So this is what? 3. Correct? And then plus f of negative 1. So plus, then I'll put parentheses around my function f. See what my f is. 2x cubed plus 2. So I'll put 2 times, what do I need to put instead of x? Negative 1, right? Because it's f of negative 1. So for the second function, my x is negative 1. And now I just evaluate this expression, right? So remember our formulas, parentheses, exponents, multiply, divide, and add, subtract. So what do I do first? I calculate what's inside the first parenthesis. 3 minus 4 is negative 1. And then I have plus. And then I have 2 times negative 1 cubed is negative 1 times 2, negative 2 plus 2, 0. 1 plus 0 is negative 1. I mean, negative 1 plus 0 is negative 1. Right? So this is just a numerical expression that I'm evaluating. I can enter it as is into my calculator, or I can do this by hand, remembering the order of operations. Good? So far so good? Hmm? Okay. Example number 3, almost the same as example number 2, except the notation is a little bit different. You will have this kind of notation, put some kind of star here or something. This is, yeah, I don't know if you've seen this before. But you see how I have k minus j here of x. This is exactly the same, just different notation for k of x minus j of x. What I need to do is take two functions and do subtraction in between. Okay? So here it's written differently in number 2, but in number 3 it's written in a new way. And then I do exactly the same as before, except now I don't need to evaluate the function, right? Because x is not given to me. I just keep x as is, as variable. So k of x is what? X squared plus 4x plus 3. I'll put it into parentheses brackets. I'll use brackets this time. So x squared plus 4x plus 3. And then minus, and I'll put brackets again, and then in the second set of brackets, I'll put the j of x. So j of x is right here, 4x. That's it. And now I need to simplify this. See, I have brackets minus brackets. Not enough space to see this clearly, but see, I have one set of brackets minus the other set of brackets, so I need to make sure that I distribute the minus 1 here properly. So it's x squared plus 4x plus 3 minus 4x. I could use parentheses. I just wanted you know, like here, because I had parentheses inside parentheses, I just wanted like visual difference between them. Right, so now I just combine like terms. I have 4x minus 4x here. They cancel out. Seems like so x squared plus 3. I don't have a key, so check me. And that is my answer. Questions? Okay. Let's move on. So number 4, same thing, except instead of plus or minus, I now have the multiplication. So this really fat dot right here, shaded point, right, shaded circle, that's multiplication. So what I need to do is, I need to take the function f of x and multiply it by the function m of x, but use -2 instead of the variable of the first function, and 4 instead of the variable for the second function. So let's do that. I'll put f inside the parentheses and I'll put m inside the other parentheses, right? Multiplication in between. Be very careful with this. So my f is 2x cubed plus 2. So 2 times, what do I put instead of x? What do I put instead of x here?
-2.
-2. And then into second set of parentheses, I put my m of x. Where is my m of x? Right here. Square root of x plus 1. So I put square root plus 1, and what goes under the square root?
4.
4. And then I just evaluate, right? So let's evaluate. In the first parenthesis, I have what? 2 times -2 cubed is -16 plus 2 is -13 times, and in the other set I have square root of 4 plus 1, which is 3. Square root of 4 is 2 plus 1 is 3. So -14 times 3 is negative, what is it, 42. Okay. So what do you think number 5 is? What's number 5? What does this notation mean? Very similar to number 3. So it's k of 2 plus f of 2. So let's just do that. Try on your own. Here. Should be good. Not yet? Okay. So k of 2 plus f of 2. What I'm going to do is parentheses for k plus parentheses for f. For the k, what do I have? K of x. Here is my function, right? Here is my function. It goes here because it's k, it's distant. X squared plus 4x plus 3. So what goes instead of x? Need more space. I'm sorry. I'm going to write below. It's just like important for me. So right here. So I have parentheses here plus parentheses here. Okay. So the k of 2. My k is right here. X squared. So I'll put what do I do for x? Positive 2. So positive 2 squared plus 4x. So plus 4 times 2 plus 3. Right? That's my k of 2. Plus f of 2. So now I need to look up what my function f of x is. It's right here. 2x cubed plus 3. So 2 parentheses, 2 cubed. And then plus 2. So now all I have to do is to evaluate this numeric expression. So if I enter this whole thing into calculator, that's totally fine. So 4 plus 8, 12 plus 3, 15 plus, is it 18? Yes? 8. 33. So that would be my answer for this one, number 5. Questions? Okay, so do number 6. Don't forget to put parentheses around every function, because this minus you'll have to distribute it, or, yes, you'll have to distribute it, I guess. So be careful. Parentheses around both f(x) and g(x). Parentheses, or brackets or something to spell a function. Yes. So now you need to open parentheses, so don't forget to distribute this negative inside there. F of x minus g of x. So I will put my f of x in one set of parentheses minus my g of x in the second set of parentheses. And I'll put minus in between. So f of x is 2x cubed plus 2. So 2x cubed plus 2 minus, and g of x is x minus 4. So x minus 4 goes into the second set. And now I just need to simplify this expression. Right? So I need to get rid of the parentheses. To get rid of there is nothing in front of the first one, so I'm just dropping it. It's like having 1 here, right? I distribute 1, there's nothing happened. But here I have minus, so I need to distribute my minus in. So minus times x is minus x. Minus 1 times minus 4 is plus 4. And I can simplify a little bit more because I can combine 2 and 4, which gives me 2x cubed minus x plus 6. What it tells you? Because I have minus in front of parentheses, I distribute it. So minus x plus 4. Questions? Okay, so we did minus, we did plus, we did multiply. So here is something new. We also can have the composition. Composition of function is when you substitute an entire function in for a variable in a different function. So we can have f of g of x. It can also be written in this notation, very similar to the multiplication, but notice that this circle is not shaded anymore, it's empty. So this is different operation. This is composition versus multiplication. Be aware of this, right? This is not multiply, this is now composition. Substitute. Variable. So if I start with f of x, right, and I also have g of x, my f of g of x is, I use my f, and instead of x, I take the whole expression for g of x and put it in. And we'll practice. Okay, so we have here several, again, 4 different functions. F of x, g of x, and k of x. And now we want to see what the function would look like if we combine them. I have g of k of x. You see how g is the most outer function? What I will do is, I will look it up, and I will put 2, and then I'll leave parentheses with a lot of space for my x minus 3. See what I did here? This is my g of x, 2x minus 3, so 2 parentheses minus 3. Right, so what happened to my x? My x, right here, is replaced with k of x. So I will take this expression for k of x and I will put it here inside instead of my original variable. So what I'm copying here is 3x. It's 3x. And now I can simplify this and get the answer. So 2 times 3x is what? 6x minus 3. And that's my final answer. See what happened? Okay. Let's try one more together. Ready? F of g of x. So my most outer, right? The outer function is f. So I'm going to look up f. X squared plus 2. Instead of x, I put parentheses with lots of space. Squared plus 2. That's my f of x. But instead of my original variable, what do I need to use? G of x. So this one. Because there is g of x instead of variable right here, I'm going to put g of x, the whole expression for it. So 2x minus 3 will go in. 2x minus 3. Now, all I need to do is to simplify this, right? All good? Yeah. So 2x minus 3 in parentheses squared, what do I need to do? Can I distribute my 2 inside? No, right? I need to FOIL. Because this is square, so I need to multiply it by itself twice. 2x minus 3 times 2x minus 3 plus 2. Correct? Because that's the square. Multiply this parenthesis by itself twice. Yes, so now we FOIL. 2x times 2x is, yes, 4x squared. 2x times negative 3 is minus 6x. Negative 3 times 2x, negative 6x. And then negative 3 times negative 3 plus 9. And then I also have the plus 2. So now I just need to combine. I can combine these two, I can combine the numbers. So my final answer will be 4x squared minus 12x plus 11. 9 plus 2. Still good? So example number 3, same thing, different notation. That's all it is. And whenever you see this, I strongly recommend you to rewrite it in this normal notation because it will help you. So K, this open circle, I don't know if there is a term for this, is there? Or we just say K of X, composition of K and F. I don't know what the term is. So I'll just rewrite it as K of F of X. And this should help me out. Right, what's outside, what's inside. Okay, so do you want to try on your own, number 3? Sure. Moving on. Okay, number 4. This one is a little bit different, right? We have a composition here, but we also are asked to evaluate for x equals 2. So what I would do, I don't know, you can skip steps, but for, at least at first, just do this first. J composition with f of x. And after you are done figuring out what is this new function, then you will substitute 2 for x. But first just do this. So this would be j of f of x. Right? And then I do the same. Yes, first I'll just do x. I'll just do x just so it's easier, like in steps. So the first step, just find what that composition function is. I don't know, do you teach it like this, Miss Osborne? Mrs. Osborne?
I would.
Right, and then...
I would rewrite it.
Right. Okay, so first we'll figure out the composition function. So my g, what is my g? Negative 5x plus 4. So what I do is I write negative 5, parenthesis with space for my variable plus 4. That's my j. Now what goes inside? My f, right? So my f is what goes inside. So x squared plus 2 goes here. I put x squared plus 2. Then I will simplify a little bit to help myself out. So I'll distribute negative 5 in. So I have negative 5 x squared minus 10 plus 4. Minus 10, right? Oh, right. So minus 5x squared minus 6. So I'm done. I know what the composition... Question?
Well, where does the...
2 went?
Yeah, why'd you put X?
Okay, so first, you see, I rewrote the original problem, but instead of the 2, I put x in it. So first, I will combine the functions, figure out what the composition function is, step number 1. And now, as the step number 2, I will evaluate it for the x equals 2.
Can you do it the other way?
You can just put 2 inside.
Yeah,
Yes,
you can do that?
Yeah, you can. Okay, so now we'll evaluate. So J composition f of 2 equals, I need to take what the function that I just calculated and evaluate it for 2. So I'm going to write negative 5 multiplied by 2 squared minus 6. Right, so I took the new function and substituted 2 for x. Now I can calculate it. What is it? Negative 5 times 4 is negative 20. Minus 6, negative 26. So that would be my final answer. You can combine these two steps together. Whatever works best.
Like if they put in the 2 for the f of x first and then get just a number and then put that number in.
Oh yeah, yes, you can do that.
That way too.
Sure.
See which one. So guys, there's another way to do this too, and so you can decide which way you like better. If you get a 2 or if you get a number.
So let's do that actually. Let me insert the page. What time do we stop? We have like 2 minutes, right?
Hold on.
1 minute?
We got no minutes.
Uh-oh.
Let us
No
go now.
minutes?
Sorry.
Also recording.
Okay.
Oh, no. Okay, no. Then just write it. Yeah, let's just write it. It's J of F of 2.
Right. So we have J F of 2, right? First I will rewrite it as J of F of 2. Correct? So this is just the number. So it's the first...
Okay. It's alright. We'll do it after lunch. By the way, get ready for some seat changes.
We'll do the same problem as we did before, but this time we'll do it differently, just for you to see. So whenever I have this composition, right, that I need to evaluate for x, what I may think of is that, f of 2 is just a number, correct? So if I first evaluate f of 2 and then substitute that number for x into j, I should have the same answer as before. So let's just do that. First I'll do f of 2, right? And I remember now what my f is. It's x squared, so I put 2 squared plus 2 and evaluate it.
I'm sorry, Star. So guys, this is that one that we did. Example 4, it's just a different way. Okay?
Yes, this one, right? Remember how I first did it? I first found out what the composition function is, my j of f of x, and then I substituted 2 for x into this new function. And that's how I got my answer. Now I'm doing it a little bit differently. I need to calculate j of f of 2. So what I'll do first, I'll evaluate f of 2 first, right? So that will be my step number 1. So my f of x is x squared plus 2. I'm substituting my 2 instead of the x there. And my my answer is, what is it, 2 squared 4 plus 2 is 6, correct? Right? So 6 is the new argument for my j. My step number 2 would be doing j of 6. See what happened? No? I need to calculate j of f of 2, right? So I have j of some kind of argument, and what that argument is f of 2. F of 2 is just the number that I get after I evaluate this function for x equals 2, right? So I'm rewriting what my f of x is just x squared plus 2 on top of your page, right? So I'm evaluating this function for x equals 2 right here. So f of 2 is 6. Now I can use this 6 instead of my f of 2 as the new argument for my function j. And that will give me, hopefully, the same number. Let's just finish it. J of 6. My j of x was what? J of x is negative 5x plus 4. So negative 5, 6 instead of x, right? Plus 4. And this is negative 5 times 6, negative 30, plus 4, negative 26. That gave me negative 26. Same answer as before. Same answer. Which way is easier? The first one or the second one? Second, third, same. But use whatever method works for you. So, yeah, any questions about this? No? Okay. So, where is it? Here. So let's do number 5. Can you try it by yourself? Number 5. It's the same steps, right? I have k of j evaluated at x equals negative 3. So either use the first method where I first figure out what my k of j of x is and then substitute negative 3 for x, or use this method, whatever works. Where? Oh, sure. So if you got 57, then move on to number 6. Try it on your own, and I'll just solve it here silently, number 5 first. So continue to number 6. Okay, so number 6 has like more depth in it, right? You have 3 layers of 3 functions combined together. So I start with the most outer, I don't know how to say it. F. What is my F? Right, my f is x squared plus 2. So I skip the argument, square it, and do plus 2. That's my f. Now, what goes inside of f? I have this j, right? So what is my j of x function? 2x minus 3. 2 parentheses minus 3. Now, I still need to figure out what to put in that empty parenthesis. And what is my argument?
3x.
It's k, right?
So you put this.
So I take my 3x in and put it inside. Now, all I need to do is simplify this, right? So how do I simplify this? Well, first I'll figure out what's inside this parenthesis. I'm using my PEMDAS, GEMDAS, whatever you learned, right? Order of operations. What's inside this first parenthesis? 2 times 3x is 6x minus 3. Right? Simplifying. And now how do I simplify these? What do I do with this square? I FOIL it. So this is 6x minus 3 multiplied by itself and then plus 2. So when I FOIL, what do I get? 36x squared
Minus 18x.
minus 18x and then another minus 18x, right? So minus 36x and then plus 9 plus 2. I can still simplify because I have these two numbers here which I could combine. And now I'm done. Yes, you got it? Good. Good.
Great job. This one, I mean, this is usually hard for students. Wow.
It looks really confusing, but like once you get it down.
Yeah. Just step by step. Right? Okay, any questions? Okay. So, go back. Okay, moving on. So, on the next page, we have some more examples. J, shaded dot, pet point. Okay, what does this mean? Is this composition?
It's multiplication.
Multiplication, very good. So this is the same as j of x times k of x. Okay? So just rewrite. Every time rewrite without this dot, so you're not confused what you're doing. So now I have two functions multiply. What I'll do is, I'll have parentheses for the first one and parentheses for the second one. So in the first parenthesis, I'll have the expression for j of x. So what is my j of x is 4x. And then in the second parenthesis, I'll have the expression for k of x, which is, oh, this trinomial, x squared plus 4x plus 3. Just multiplying function, two functions, keeping the variable without any substitutions. Okay, so now, how do I simplify this? All I need to do is, distribute, because this is the first is monomial, so I just distribute. 4x is multiplied by every single term within that large parenthesis. So it's 4x cubed plus 16x squared plus 12x. I'm done. So this is easier. The new function is just a polynomial, cubic polynomial, right? Cubic trinomial. Number 2. So now I have division. F of x divided by g of x. So once again, I just rewrite, right? I have this fraction or this division. Numerator is my f of x, so I just copy. 2x to the third plus 2. And what goes to the bottom? G of x is 4x. Done. Do the next one on your own. I don't know why I'm doing it. Make sure you have the same answer as I did. Same? Jaden, same? Or number 3? Different? So we're looking at these functions that we got at the end. So the first one is just the polynomial, normal polynomial. What is the domain of this function? What values for x can I choose that I would calculate this, evaluate it? Can I choose x negative number and calculate this? Like -1. Can I substitute -1 instead of x and evaluate?
Yes.
Yeah. Can I choose positive 10? Yeah. Can I choose 0? Yes. Right? So I can choose any x and calculate what this will become, right? For x, I can choose any value. No restrictions on the domain, we say. Okay, so what about this one? What values of x I cannot choose? Any ideas? Huh? Well, I think I can choose -1, right? Because this will be negative number and then +2 and then divide by -4, or, negative number. I think negative number is not a problem. What will be a problem here? If I enter into calculator something like 2 divided by 0, what will I get? 2 divided by 0 is 0, try.
Oh.
What will be 2 divided by 0? What is that? Undefined. Error, right? So we really don't know how to evaluate if the denominator is 0. That's a problem for us. Okay, so this kind of function, the rational function, has a restriction on the domain. That's what we say, restriction on the domain. We cannot have the denominator 0. What about this one? Do you see any problems with this one? You cannot use the negative number under the square root, right? So if I choose x equals 0, put it 0 minus 8 gives me -8, and then I have to calculate square root of -8. If I try, I'll get error, right? So once we do all of this, we need to start thinking about all these different restrictions on the domain. The denominator of a fraction cannot be 0, and underneath a radical or square root, we cannot have negative number. So cannot have negative number, cannot have 0. These are the restrictions for the domain. So once again, the same examples from before, values of x that work for number 1 and number 3. So what was our answer for number 3? 4x cubed. I'm just copying from before. That's 16x squared plus 12x. What is the domain of this function then? If we say we already determined it unrestricted, right? All real numbers, so negative infinity to infinity. All real numbers, right? You can also use the set builder notation like this. All real numbers, right? Okay, so what about the next one? 2x cubed plus 2 over 4x. So 2x cubed plus 2 over, what was it, 4x? 4x. Okay, so what is the domain of this function? What values of x I could choose? Let's do set builder first. X, what kind? 4x cannot be 0, right? That's what we want. We cannot have 4x equals 0. So x could be either less than 0 or more than 0 or greater than 0, but not 0. So x not equal to 0, right? X can be anything but 0. So if I wanted to write this in my set interval, in my interval notation, how would I write this? Negative infinity to 0, union 0 to positive infinity. Everywhere parentheses, because I do not want to include 0. Say again. Oh, what about -1/2? That's fine, right? I can have like -0.0001, and that's super. As long as it's not 0, I have to go all the way to 0.
Star, can we show them that we could take everything in the denominator and make it like not equal to 0 and solve for x, then that'll give us the number.
All right, we will have those examples later, right? Yes.
And just because I think that's what Jaden was asking.
So you mean like this? So we need 4x not equals to 0, right? Divide by 4, divide by 4, x not equals to 0. Like this? All good? Do something.
Yes.
Yes. Okay. Last one. So the last one was with the radicals. Square root of x minus 8, right? So square root of x minus 8. Once again, we already talked about this. What don't I want to have under the radical? Negative number. So what I need to figure out, what is my domain? X minus 8 has to be positive or at least non-negative. So greater or equal to 0, right? This is what I want. So let's solve plus 8 gives me x greater than or equal to 0. This is what I want to include. So in the set builder notation, I would have such all x such that x is greater than or equal to 0. This is my domain. Oh no, I'm sorry, not 0, 8. I'm adding 8 to both sides. Right, so x minus 8 must be non-negative, so plus 8 on both sides, x is greater than or equal to 8. That's what I want to include.
So,
Interval. Good. In interval notation, how would I write this? 8 to infinity, parenthesis or bracket? Bracket. So that's the domain for this new function. Questions? Okay then. Oh, here we just, let's rewrite. So when doing function operations, there are two domain restrictions you must be aware of. Remember, underneath even radical, only even, right? Remember that if I have the cubed root, I'm okay with negative numbers. If I have ninth root, I'm okay with negative numbers. But if I have even root, I don't want negative numbers. So only for even radicals. Underneath must be positive. Non-negative. No, don't put positive. Non-negative. Positive or 0. 0 is fine. I'm sorry. Okay, so greater than or equal. Because 0 is fine. And then denominator of a fraction cannot be 0. Cannot equal 0.
what's non-negative mean?
Non-negative means either positive or 0. You've never heard this term?
No.
Non-negative? So should we write positive or 0?
Yes.
Or learn the new term, non-negative. Greater than or equal to 0. Non-negative. Kind of self-explanatory, right? Hannah, are you good? She will be doing the flashcards at home. Like you wish.
No, I mean, but it's cool though. Doesn't it make sense? You can't say 0 is a negative or a positive. You can't say positive because then you're excluding 0.
Sure,
Right.
zero's positive.
0 or positive, yes, you can. Non-negative, learn it. That's useful.
So far.
If either one of these occur, you must indicate that there is domain restriction. So domain restriction. The values of x that make this happen are not valid values for x. Okay, if there are no other questions, we'll practice. So let's do the first one, I guess. Okay, so let's do the first one together, the next two you'll do by yourself. Well, actually, let's do all three together. Okay, so j of x minus k of x, right? Oops. I have just two functions that I need to subtract. Minus this one. Okay, so I have parenthesis minus parenthesis. The first parenthesis will get j of x, which is what? 2x squared plus 5x minus, put parentheses around each fraction, just to make sure you're distributing your negative correctly. So my k of x is 5 minus x. Okay, so I have here j of x, and I have over here my k of x. And now I just need to simplify. So the first parenthesis I can just drop because there is nothing in front. So I have in 1 times, right? I distribute 1. So it's 2x squared plus 5x. And then for the second one, I have minus in front of parentheses, so I have to distribute that minus in. So I have minus 5 plus x, right? And now I can combine. 5x and x can be combined. I have 2x squared plus 6x minus 5. Done. What is the domain for this function? Kevin, what is the domain for this function? Regular polynomial. Are there any restrictions on the domain for polynomial? Let's look here, right? The restrictions are when we have the radicals and when we have denominators. That's it. Do we have any radicals or denominators here? No, right? No roots, no denominators. It means that we have no restrictions. So my domain is what? Negative infinity to infinity. All real numbers are good. I can choose any x and evaluate. Teddy, are you okay? Yes, good. Number 2. What does this mean? Is it multiply or composition?
Composition.
Composition. Multiply would be the shaded one. So I will rewrite, just because it's easier for me to process. This is h of f of x. Okay? So the h comes first. So I'm going to copy this square root of 3 minus something for the argument. And what do I have for the argument? I have f of x, right? So this one, okay, f of x comes here. So instead of argument into for the h, I will use the expression for f of x, which is negative 3x plus 2. Negative, oh, I can see. Negative 3x plus 2. I'm trying to make it better with the colors, but I think I'm making it worse. It's like toddler with the pain.
That color's kind of dark, but it's okay.
Yeah, okay. Okay, so I need to simplify this, yes.
Putting the 3 minus.
So h is square root of 3 minus x, right? So h is on the outside. I start with the h. Square root of 3 minus, and then instead of the argument for this function, I have to put f. So I take the f of x there. Put it there.
Would you distribute the minus? So
Yes.
you can
So when I'm so when I simplify, I need to distribute minus inside parentheses. So I have 3 plus 3x minus 2. And when I combine the numbers, I will have 1 plus 3x. That would be my final answer for this composition. So now what? Domain. Is domain going to be all real numbers? No. Ava, what should I have? What is my restriction for this domain?
The negative.
So whatever is under the radical, which is 1 plus 3x, should be what? Hmm? What do I need? What is my requirement? What is my condition for this? Greater than or equal to 0, right? So let's solve what this means for the x. Minus 1 on both sides. So I have 3x greater than or equal to negative 1. Divide by 3, x greater than or equal to 1 over 3. Negative 1 over 3. Right? No? Dylan? Good? Right. Whatever the expression under the radical is cannot be negative. But then I have to solve for x. Right? And x could be anything after I simplify. So let's see. What if I give you this example, right? What if I had square root of negative x? This is my f of x. Right? If x is negative 4, then my f of x will be what? Square root of negative 4, which is just square root of 4, which is 2. Right? I'm okay. 0, square root of negative 0 is just square root of 0, 0. I'm fine. But what if I have 4? My y is square root of negative 4, which is square root of negative 4, which is error. I'm not fine. This is not good. Right? So I have to start with what's under the radical and make sure that that expression, after I evaluate, is non-negative. X means whatever. Right? So that's why we start with 1 plus 3x greater than or equal to 0. And then this is what we get at the end after we solve that inequality. So the answer for the domain would be all such x's, or x such that x is greater than or equal to negative 1 over 3. This is in the set builder notation, and I could also write it in the interval notation, which is what? Negative 1 over 3 to infinity with the parentheses or brackets. Okay, try to do the next one on your own. Let's see if silently. If you don't understand something or your answer is different, please say so. Make sure your domain for number 3 is correct. Here's some concerns.